Hello guys, I am Pramila Rupasinghe. Everyone warmly welcome to my video. Today I am talk about the scanning tunneling microscopy in nanotechnology. This is my content, introduction, basic components of scanning tunneling microscopy, applications of scanning tunneling microscopy in nanotechnology, limitations and challenges of scanning tunneling microscopy. Finally, I get my references. First of all, I get what is scanning tunneling microscopy. Scanning tunneling microscopy, an imaging technique used to obtain ultra high resolution images at the atomic scale without using light or electron beams. It was generated in 1981 by Judd Bining and Heinrich Royer of IBM's Zurich lab in Switzerland. The invention deserved Nobel Prize for 1986. Scanning tunneling microscopy sensors the surface by using an extremely sharp conducting that can smaller than 0.1 nanometer with 0.01 nanometer depth of resolution. The scanning tunneling is an electron microscope that transmit three-dimensional images, electron cloud, around the nucleus. The scanning tunneling microscopy allows the inspection of the properties conductive solid surface at an atomic size. It is a very important technique determining the atomic structures and electronic states of the surface under investigation. Surfaces can be viewed at the atomic size to the high resolution that 0.1 STM has. So, these are basic components of scanning tunneling microscopy. This image is a rough diagram of scanning tunneling microscopy. The basic components are tip, sample, piezoelectric scanner, feedback loop, amplifier, and computer. The scanning tunneling microscopy tip is a sharp metal wire made of tungsten or platinum or iridium. The sample is placed on a conductive substrate such as a metal plate and is scanned by the scanning tunneling microscopy tip. Piezoelectric scanning is capable of making atomic scale movements. The feedback loop is used to maintain a constant current between the tip and the sample. The amplifier is used to amplify the small current that flows between the tip and the sample. Finally, the computer is used to control the scanner and the feedback loop, as well as to process, display the data and generate 3D image of the surface of the sample based on the data collected by the scanning tunneling microscopy. So, these are some applications of scanning tunneling microscopy in nanotechnology. It is a powerful technique that allows the imaging of surface at the atomic level. It's a key tool in nanotechnology research, allowing scientists to study and manipulate individual atoms and molecules on the surfaces. Surface analysis, nanolithography, molecular electronics, surface chemistry, biomolecular imaging. Surface analysis to investigate the topography and electronic structure of surfaces at the atomic scale, as understanding the properties of materials, designing new materials like that. Nanolithography to manipulate individual atoms and molecules on a surface, allowing for creation of nanoscale patterns and structures as electronics, photonics, and biotechnology like that. Molecular electronics to study the electronic properties of individual molecules on a surface as transistors, sensors. Surface chemistry to study chemical reactions that occur on surfaces at the atomic scale as understanding the behavior of catalysis, designing new catalysis. Final one I get biomolecular imaging to study the structure of biomolecular molecules as understanding the function of biological molecules, designing new drugs like that. Okay, then I get some limitations and challenges of the scanning tunneling microscopy. Limited imaging range, surface requirements, tip wear, temperature limitations, imaging artifacts. First one, limited imaging range. The scanning tunneling microscopy works by scanning a sharp tip over a surface at a very close distance, typically within a few angstroms. Another one is surface requirements. Scanning tunneling microscopy works best on conductive surfaces, so it cannot be used to image insulating materials. Tip wear. The sharp tip of the scanning tunneling microscopy can wear out over time, which can reduce its resolution and accuracy. Temperature limitations. The scanning tunneling microscopy typically operates at room temperature or below. Final one I get imagining artifacts. The scanning tunneling microscopy images can be affected by various artifacts, including tip sample, interactions, electron noise, and thermal drift. So these are my references. Okay, thank you all being with me. Thank you.